Welcome back to this technical session. We have an exciting lineup of 9 talks ahead, and it is our privilege to have Dr. Bhavesh Gohil, Associate Professor at SVNIT Surat, as the session chair. Dr. Gohil is a distinguished researcher with expertise in distributed computing, IoT environments, and cybersecurity, particularly in cloud, edge, and fog computing. He has contributed significantly to the field through numerous publications in reputed journals, making his insights invaluable to today's discussions on cutting edge AI advancements. We sincerely thank you, sir, for accepting our invitation as a chair in this session. I now invite Ms. Swati Saxena to extend a warm welcome to Dr. Gohil with a bouquet of flowers. So let's start with our presentation. First of all, the rules for the presentation is you will be given total of 15 minutes. In that 10 minutes will be for the presentation and 5 minutes for the question answer talk. After the 10 minute a buzzer will be given, and for the first presentation we have paper ID 121, deep learning based on YOLO face model design for high performance and enhanced face landmark detection, from Dr. Chi Peng Fang.
Yes. Just a second, sir. Give the panelist to me. And
Hello, everybody. Could you hear me?
Yes, sir, you are audible.
Okay, yeah. So then please wait a minute. I would like to share my screen. Yeah, so maybe, yeah. Oh, yeah. Excuse me, could you see my screen?
Yes, it's visible.
Okay. Okay, so can I start my presentation?
Yes, please, you can start it.
Okay. Ladies and gentlemen, this is my great honor. I can present the research from my graduate student in this international conference. Yeah, I'm Zipeng Fan from National
Presentation
Zhongxin.
is not visible. Sir, your
Ah,
presentation is not visible.
not visible. Screen is not visible. Yeah, so
Screen is
maybe
visible, the presentation is not visible.
presentation is not visible. Okay, yeah, maybe
Yes.
I share. Yeah, so sorry. So, sorry, maybe. mm, so it is okay?
Yes, now it is visible.
So maybe, sorry, maybe I cannot use the full screen mode. So may I use this not full screen mode to do my presentation?
Yes, you may.
Yeah. So yeah, because the time is limited. Okay, very sorry. So yeah, so maybe I remove the next slide. Yes. So yeah, introduction. So I would like to quickly introduce my research. Yeah, as we know, the rapid advantage of the technology, the face detection technology, has been increasingly applied in our daily life, especially for the real-time monitoring of drivers' facial feature detection, to application to the driving monitor system. And for the driver's fatigue detection, as we know, how to detect the change of the eye state is very important, such as the blinking frequency, eye openness, and the eye close state. So that is why we would like to do this research. Yeah. So in this study, how to accurately and rapidly detecting the driver's eye state is a core challenge for the to detect the fatigue driver's monitor. So in the existed face detection technology, we know the traditional convolutional neural network and or the DLIB, that's called facial recognition library based on traditional machine learning, and the traditional 68-point face landmark detection technology can be also used to the face landmark detection and also for the face detection. However, in this traditional method, they maybe have some limited to do the face detection and the face landmark detection. So in this study, we introduced the Euro-based face landmark detection to do the faster detection and the robust detection for the face landmark. Okay. So next, I would like to share the objective. This study aimed to introduce Euro technology to leveraging his efficient object detection to enhance the accuracy and real-time performance of face landmark detection. Just as I explained, especially for the application to the driving assistance system. So, especially our object is to develop a Euro-based method to maintain high recognition accuracy and under general condition, especially for the driver when the driver's face is partially occluded or viewed from different spatial different angles. So leveraging his end-to-end object detection framework, we think Euro can quickly locate and identify key features, key point, and more robustness for the face landmark detection, especially for the large angle change of the driver's face. So in this slides, I would like to quickly show our method. I think our method is simple. Yeah. So step one, in these slides I would like to introduce the Euro-based model. As we see the figure one show the architecture of the Euro V5. So in Euro V5, this show the input resolution is 1640 by 640 by RGB, three-channel input. First input through the focus module, and after some spatial operation, such as this shown in this slide, and the backbone operation, head operation, and in the Euro V5 operation, this operation creates 4 complementary images that retain similar content without any information loss. Then, for example, the original RGB 3-channel input will become a 12 channel after stacking, and the newly created image is then passed through a convolution operation, ultimately produce a downsample feature map without losing information. So I think this slide just introduce the basic idea of the Euro V5 based model. Then in this slide show maybe this is our main contribution to improve the detection by using the Euro V5 model. So in step 2, we do the data generation and training by using this Euro model. And firstly, we introduce a data by data set, and the data set is the open source, and it's called maybe 300W, large face landmark data set. And this data set is this index file is processed by using the Python script write by my graduate student to generate the initial landmark and the image. After that, the script is customer developed. The script is a customer developed tool that use Euro V5 face to detect the face by the five key point. As we know, the original Euro V5 only detect the 5 key point, and then we combine the DLive to extract the another 12 landmark for I feature point. Just as we can see the figure 2. Well, this tool is write by my graduate student, and after the training data is generated, and we can use this relabel image by adding the 12 additional landmark to train the Euro V5 model. So in this slide show the, oh, sorry. So in this slide show the our result. So in table 1, list is the result of respective training data set. We can see by the respective training data set, if we use in the Euro V5 or Euro V7, we can have a smaller processing time compared with the traditional FPLD or DLive or CM method. And in table 2, I would like to share the result. For example, if we use in the Euro V7 based model, and by using the additional labeled landmark, in table 2, the M15_4 means the weight file generated after training with a 15 landmark, and the performance the force transfer learning. So we can see if we retraining the Euro V7 model by the enhanced the face landmark feature, then we can obtain the more accurate feature face landmark detection, and we can see the Euclidean distance between the detected feature point and the marker point will be smaller by using our proposed Euro V7 based method. Next, this also show our experience result. We can see in figure 5, we can see when the yaw of the face change by 15 degree, both of the traditional method, including CN and the PFLD method, are unable to detect the face landmark correctly. Yeah. Shown in the figure 8. However, our method can detect it well. Yeah. So, but if the yaw angle and or maybe or the that is if the face angle change too much, all methods are unable to detect the face landmark correctly. So the result show the method B. Finally, I would like to use in this slide to do some comparison between the traditional method and our Euro V7 based landmark based method. So in table 4 show the detection result with measurement yaw and the pitch degree by using the image file from the camera. In table 4 we can see our Euro by using our Euro base, Euro V5 base or Euro V7 base method. When we do the real-time test by camera, our proportion method can performance more, can performance maybe more robust to detect the accurate face landmark compared with the traditional method. So, now I would like to show some conclusion. So, I think in this study, we just simply use the Euro-based technology for face landmark detection, and by using the labeling technology, adding more face landmark and do retraining, we can we can obtain the higher detection accuracy when dealing with the multi-angle change in the driver's face. And yeah, so the results show after combine the Euro-based technology and the increase in the additional face landmark to do the retraining, show the combine this method, we can gain the advantage of the accurate feature detection from the Euro model, and also can obtain the advantage for we can accurately detect also accurately detect the face landmark when the face angle change large. So I think it is can be this application or this study can be used to the real-time detection for the DMS system in ADAS application. Okay, this is a reference. Thank you very much. So, any question from the audience?
Yes. Bye.
Hello.
Yes, please.
Yeah, hello, Professor. One thing, would you please share the design novelty introduced for the face detection in YOLO? That's right.
Oh, yeah, yeah. So yeah, maybe yes. Thank you for your question. Yes, in the table, the 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 maybe the result we noted by Y means the yellow, and the W means the result by the white color, and we if we note the Y means the detection result is yellow. Yeah.
So, is it the YOLO model as it is, or we have modified the YOLO model for face?
Oh yeah. Thank you for your question. So yeah, so we don't change the original architecture of the Euro model. As we know, we using not the newest Euro model, Euro V5 or Euro V7. As we know, the traditional or the original Euro V7 model, this model also can provide the fundamental or basic face landmark function. However, the original Euro model only can provide uh, five uh, five uh, 5.5 face landmark. These 5 face landmark cannot cover the key point about the eye state, about our eye. So in our study, we increased we add more than 12 key point about the eyes face about the eyes face landmark because we would like to detect the key point or face landmark around our eye. So
Okay, thank you.
So I hope I can answer your question. Yeah.
Thank you.
Okay.
Hello, Professor Fan. This is Professor G.R. Sinha. Can you hear me?
Yes. Professor Sinha. Yeah.
Thank
Yeah. Very nice to hear you.
Thank you so much for your contribution. I missed the beginning of your presentation. I think the last part I could see it's excellent work, and I'm very happy that we know each other for last, I think, for more than 4 or 5 years. And I'm glad that you have contributed your paper in our conference, and hopefully looking forward to see you here in person in our university very soon.
Yeah. Thank you very much for your invitation. This is my great pleasure.
Maybe
Thank you very much.
Please plan a visit to our university. Thank you.
Yeah.
Thank you very much.
Yeah. Very appreciate your invitation. Yeah. It is my pleasure. Yeah. Thank you very much.
So someone has raised hand from the online list. You may ask your question. Yes, Dali, you can ask your question.
Okay. Hello, sir. Can your system handle lighting conditions?
Oh, lighting condition. Yes.
Yeah.
Your question is very good. Yes, that is why we use the Euro V7 based method. As we know, the Euro based model can provide a very strong object detection capability for the object detection when the light change. So as we know, when we design the driving assistance system, the in-cabin the in-cabin condition, the lighting condition of the driver's face must be changed very large or frequently. So if we don't use the Euro-based model to detect the face landmark, maybe the other method may be fail to detect the face landmark when the lighting condition are very bad or change very large. So this is why we choose the Euro model to do the pre-processing to maybe the pre-processing. We use his robust object or feature point detection capability to find this feature point. So this is, and the Euro model can provide the robust capability to overcome the lighting change. Okay, so I think I can answer your question correctly.
Okay. Thank you.
Darli, can you please accept the request to become the panelist?
It's okay.
Yeah, okay.
It's okay. Syama Dali, Nekaumla. Syama Dali, good morning. Minglaba.
Sir,
Okay, got it. Okay.
Are you here?
Can you turn on her video?
And Darli, can you please turn on your video too?
Yeah, please wait.
Yeah, sure.
If there is problem, no problem. I mean, don't. Is there any problem?
Yeah,
Current is not there.
I have problem to share my videos.
Okay. So Minglaba.
Hello, sir. Long time no see, sir.
How are you, Nekaumla?
Yeah, Nika Malaysia.
Thank you so much. You have joined from Myanmar and you have worked with me. It's very good to see you. Just I wanted to say thank you. And one of my friend who joined from Taiwan was presenting the papers. I just wanted you to introduce with him. Nice to see you. Thank you for your contribution. Thank you for submitting the paper. Good luck.
Thank you. Thank you, sir. Thank you.
Minglaba.
Based it. Miss.
Thank you, Ms. Dale and Dr. Chin Peng Feng. Moving on to the next paper ID 120, an innovative RoboPin Nodi for piano performance using Lego Mindstorms EV3 from Dr. Kyat from yes, Cha The from again from Myanmar. Yes.
Hello, good afternoon.
Hello.
Good afternoon, Professor.
Yeah, your full video is not showing. Can you like adjust it so your full face can be shown?
Okay. It is okay.
Yes, it's fine. You can start sharing now.
Okay, thank you. Can you see my share screen?
No, it's not visible.
Oh, sorry. Sorry, I need a little time because my laptop is a little busy. Busy with hello.
Yes.
Can you hear? Yes.
Is there any problem coming while sharing your screen?
My share screen is loading.
So would you like us to share the screen for you if it is possible?
Yes.
Yes.
So Chacha, we have your PPT so we can share it for you and you are just present from it.
Okay. Thank you.
We are not sharing. It's her.
Her screen is now visible. Chacha, your screen is visible now.
Hello. Hello, Dr. Chacha The. Can you hear me? Hello. Oh, maybe you can take the other one.
But she
Yes,
she needs to out of a range.
Next.
Okay, so let's start with the another paper ID Paper ID 112, MHC CNN, a CNN framework for stream selection in secondary education using modified Huffman coding, from Dr. Kapil Sethi.
Yes, ma'am.
Yes, sir. You can now start sharing.
Okay, okay. My screen is visible to all of you?
Yes, sir, it is visible.
Okay. Good afternoon, everyone. It is a great honor for me to present my paper today. My paper is titled MHC CNN, a framework for stream selection in the secondary education using the modified Huffman coding. And my paper ID is 112. Actually, in this, my research, we explore an innovative approach to the stream selection in the secondary educational. As you know, it is an essential aspect for the guiding student toward the making informed decision to their academic futures. So now we have to just move on the first slide. This is my content, abstract introduction, review of literature, material matter, results. After the result discussion and conclusion, then the last one is the references. This is my abstract. So in the introduction part, as you know, the secondary education is the very crucial in shaping student careers as stream selection, and it impacts their future for success. While choosing a stream, it can be very difficult, and poor choices due to peer pressures of lack of understanding can lead to failure or dropouts. So the our current guideline systems or the guidance systems often overlook students, the personal interest and earlier performance. In my research, this is a research aim to develop a data-driven system using a machine learning, incorporating the factors like interest, family background, the prior education, and it helps to students for maker better stream choose based on the successful examples. So this is by the introduction, and we need a proper guide, proper tool for this, so can the student is easily get all the information from that tool. In the review of literature, so many researchers are doing the same work, but it only for the graduate student, not only for the secondary school educator students. The as per the literature, the education data is mining and machine learning and education highlights the various approaches to improve the student performance and the decision making. So McWatt Lee, the one of the authors, is explored the relationship between the mining to access the learning material and the effectiveness, but did not consider the intermediately factor affecting the outcomes. As also the SB constraints using the machine learning participants with the M5 rules to predict the student grades and empathizing its role in the shaping careers and enhancing the sports systems. The third researcher is C. Roman Rowe. It discussed the growing use of the data mining in the web-based education system, calling for the further research in this area. And the ex Shing Wallin, and he is focused on the automated performance evaluation system to predict student achievements and identify at the risk student, reducing the teachers' workload. And the last one is the constraint also highlights the significance of the regression algorithms in the overcoming patterns in the educational data to improve the performance. Uh, the Pang, it demonstrates how emotional constraints extracted from the text and using categorizations algorithms can provide the essential is the emotional factors influencing learning methods. Finally, these studies are underlines to potential for the machine learning and data mining to enhance the education by providing and personalization of recommendation and their sports. So this is the fund. These are our challenges and gaps. As per the challenges and gaps, you can see all of the models are the graduate focused models. They cannot be used the secondary school students like 10 plus 2s. Okay, because as you know, the 10th it is a board exams and it is very important step for the every students to make a career start, and they cannot be decided which subject is very important. Either they are selected for the science, medical, and arts and commerce. So this is a very so lack of the intermediately factors. Many studies ignores these kind of the factors, and like family emotionals. Sometimes the family persons are like a doctor, so they are just trying to the son is also make a doctor and engineer also. So these are the challenges, are the gaps they identify in the current education models. These gaps highlights the area where existing systems fall shortly, and especially in the secondary education, and indicates the need for the more personalized and data-derived solutions that account for the emotional, personal, and the family factors. So these factors are very lack of the focus on early detection support system. Individually, they can recommendation for the future emphasis, and they need for the improvement in stream and subject selection guidance. Okay, so these are our objectives. The purpose of our this model is MHCCNN. As per the research gaps, the current study we propose to use the novel machine learning algorithms like modify of when coding for offering trails, recommendation, and challenging, enhancing the decision process for the students. And the expected outcomes for our model is to include improved student satisfaction for the better alignment for the each subject choice and with their goals leading with the enhancing academic performance. So these are the our objective, and these objectives we have mentioned. For the material methods, we have collected the this is our framework. In this framework, we have data collection. After the data collection, we have going for the pre-processing of the data. After that, we have normalization of data, and we select some features from the important features from that data. After the feature selection, we going for the machine learning algorithms, and we use in these 5 different machine learning algorithms. After that, we going for the validation. So, firstly, we discuss the data collection. We collect the data; it's our own, and we called as a student data set. In this student data set, we have 550 students across various Indian institutes like IITs and medical college. And the medical college is very high range of medical college. So in this data set, there is a 240, 240s are girls, and the rest of the are the boys data set. The data set includes the 24 survey questions categorized into 6 categories, like students are belonging to which region and what are the previous education, and in the household, what is the category of your household, like your father is doing a government job or a private job or something. Then we are asking for the personal questions also further, and we also go for the some questions related to the education also. how much they time to spend for the studies. They are taking some and any coaching or something or other things. And the last category is the inspirational futures. So after these source of data, we going for the pre-processing steps. We clean the data because when we are going for the data collection in the form of questionnaire, some of the students are fill the forms, but they are missing some fields. So we clean all these categories and transforming the raw data into the format suitable for analysis. And after that, the missing values, we normalize and duplicate data, we remove that and we put it into our model. After this pre-processing, we go for the normalization. As you know, the normalization has followed by the data processing, which the data removes the outlines and enhancing the classification for prediction accuracy. So we are going for the feature selection. We are using the Baker software for feature selection, and after the feature selection, we are going for the algorithms. We are using the 5 different algorithms like SVM, NetWise, K-neural network, and feed-forward neural network. And the MHC CNN is our the novel method for this method is different from the other algorithms. So in this algorithm, we suggested the structure compared with the 15 layers and the neural network. And in this network, we have 4 convolutional layers: batch normalization, ReLU activation, one total connected, and one dense layer is there. The first layer is convolutional layers, and it contains the 128 filters with filter size is 2, and the corresponding second layer is the 128 filters, and the size is 4. The third layer, we have to go for the filter size is 3. So this is the we categorize the data into 2 groups, that is medical and non-medical data, because as per the our data collection, we take the data from the medical institutes and IITs. Okay, so this is our work. After this, all the framework, we find some results. So in this result, you can see that the FFN, the MHCCNN, it gives the highest accuracy as compared to the others, and uh, and the specificity and sensitivity is very high as compared to the other, and the MSC CESS is the other. In this results, the data was split into the 90 and 10 ratio for training, like 495 for we are using for the training and 55 for the testing. And again, the algorithms were used. We have already mentioned, and the FN achieved the 97.92, 87, sorry, 87.92% accuracy, while SVM had 76.08% accuracy. The KNN performed better than the SPM with the 85.52%, but had over the lower specificity, sensitivity, and MCC. The naive performed the worst performance, and after that the MSC CNN outperformed all with 94.86 accuracy, with the 0.92 specificity and 0.93 sensitivity, and the MSC CNN is 0.83%. So this is our results, and as per these results, this is our graph. We show that the accuracy MSA CNN the highest give the performance in this specificity. It also gives the some highest by the MHC. This is the performance is graph by the, and after that we going for the discussion. So this study emphasizes the importance of the student subject stream selection in the secondary schooling, particularly for the field for the medical and the non-medical and the engineering students. Many students make the poor choice due to peer pressure and lack of guidance and limited information leading to the higher dropout rates. Because as you know, some when the student is that getting the achievement, they drop for that course. So this is also the reason for not picking the good subject selection. So this research highlights the influence of the family backgrounds as a parental education using a questionnaire. We using data on the students' backgrounds, and concerning we collected that the MSc CNN models outcomes the traditional algorithms with 93.75 by accuracy, and it offering a personalization solution for the stream selection and aim to reduce the dropouts by the considering students' interest and influence factors. So this is the conclusion part. In this conclusion, the students present a novel MSc CNN approach for the stream selection using a student database with various factors like geographical background and personal traits. The models converts the text into the numeric from and categorize into the deep learning models. And
Sir,
MSc, yes, yes,
sir,
please.
your time is up. If you could wrap it up quickly.
Okay, ma'am. This is my left slide also. So after that, its accuracy could improve, so making the acceptable globally. My future work is to include the expanding the data set, adding the factors like mental health, refining the models for the more personalized recommendations to guide students to in their education and career choice. So this is my references, and thanks for this presentation.
Dr. Kapil,
Yes, sir.
good work. The thing is, I would like to know about the
Yes, sir.
MCC evolution parameter you have used, right? In the
Yes,
pop.
sir.
Are you going
Yes,
to
sir. Yes,
use
sir.
all the binary classifiers or what?
Sir, we are using the various different classifiers for particular work. And so, in this work, we are using so many classifiers. And at first, finally, we are just going for the details and which give classifier gives our accuracy.
So, the importance of MCC in your
Yes,
work,
sir.
what
Sir,
conclusion you can make from the MCC results?
okay. Sir, actually the NCC is a correlation coefficient. So it just gives the details what the database data set is using. It is effective for your model or not.
So, is this binary classification or multimodal?
Multi-model, sir.
So, how many classifications are there? I mean,
So 3 to 4.
okay. And the 24 questions you talked about, any
Yes,
other
sir.
kind of input you considered, or only those 24 questions?
Sir, actually, when I am going for the data collection, so if I am adding the more questions, the questionnaire time is so many, so much goes high. So according to the class, according to the student class and the engineering students, we concise our questions. So we take only 24 questions.
And the data set is also very small, considering the deep learning, machine learning models.
Yes, sir. Yes, sir.
What about that?
Actually, we do not, sir. Actually, permission नहीं मिला जिसकी वजह से हम we take
Understand.
all
Okay.
more data. Yes, sir. Yes, sir.
And suppose your model is not there, so which one
Yes,
you
sir.
would prefer in the existing one? The latest one, that one you have, and I think I was also expecting a comparison with the existing one at the end.
Okay, 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 sir. Sir, actually, the previous जो previous model है, they are focusing on the graduate students, like college students, graduate students. They
But the
are not
same model,
going
if
for
you
the.
apply, same model, if you apply, then will it give a good result compared to ours, or maybe?
Yes, sir. Good result. It did give the good result, sir.
Okay, thank you. Best wishes.
Okay, sir. Thank you. Thank you so much, sir.
Thank you so much, Dr. Kapil. Moving on to the next paper, paper ID 122. Facial expression recognition for individuals with intellectual disabilities using machine learning by Dr. Amol Chaudhary.
Okay, ma'am. Is my presentation is visible there?
Yes, sir, your presentation is visible, and also please turn on your video.
Okay, just a minute.
Yes.
Okay. Presentation.
Yes, sir. Yes, sir.
So good afternoon, all the respected teachers and my dear colleagues and friends. We all are quite lucky that we are able to share our thoughts verbally and non-verbally. So with the same concept, I have given the presentation on my paper ID 122, and my title is Facial Expression Recognition for Individuals with Intellectual Disabilities Using Machine Learning. Myself, Amul Chaudhary, and my mentor is Dr. Pankaj Doshore, and I am from Sandeep University, Nashik. Here is my flow of presentation. In the slide 1 and 2, abstract and title slide. Slide 3 to 7 are my introductory slides. Slide 8 is my objectives. 9 to 12 are material and methods. Slide number 13 is my result. 14 is conclusion, and the last one are the references. So, as I already told you that we are quite lucky that we can communicate verbally and non-verbally. We all are able to share our feelings, share our expressions, or share our thoughts. We can also express our moods, that we are happy, or we are sad, or we are surprised, or we are angry. And we are able to share whatever in our mind to the society or to the outside world. But this is not the same case in the people with the cognitive impairment. They are not able, these persons are not able to share their expressions to the outside world verbally, or they cannot share their moods, or when they are ready to take medicine, or when they are ready to go for sports, or when they are happy. So for that, here the picture comes for the nonverbal communication, and this problem will be solved, or issue will be resolved with the help of facial expression recognition. With the help of facial expression recognition, we can able to extract what these persons can feel. Here, the computer interactions relies heavily on facial expression, which are important in social interactions and emotional interpretation. AI techniques such as machine learning are commonly used for facial expressions recognition and emotion detection. Emotion detection has the potential to revolutionize various fields such as security surveillance, medical treatment, and many more. So, facial expression recognition is crucial for human computer interactions. It supports individuals with cognitive impairment, particularly those with mental retardation. Enable personalized interventions by caregivers, therapists, and educators. Promotes better emotional and behavioral outcome for these people. The human face is important for communication and understanding emotions through facial expression. Some emotions expressions are universal, like happiness, sadness, anger, fear, disgust, surprise, and neutral. So these are the facial expressions that we have to extract from the people those are not able to share verbally, or the cognitive impaired person. So this is the scope of the work. Here, the improved facial expression recognition. Our model accurately and successfully recognize and classify a wide range of facial expressions, including subtle or complex ones. The second one is the application to the management of mental illness. Here, they will examine the use of the facial expression recognition in monitoring the functioning and emotional state of the individuals with mental illness, while the model techniques it aims to provide insight into their behavior, which can be useful for careers and the mental health professionals. The next one is the enhancing social and emotional skill. This will examine how improved facial expression recognition can contribute to the development of emotional intelligence and social interactions. Also, the next one is the integration with the existing technologies. Here, we can integrate it with the existing technologies or the surveillance systems for real-time monitoring and facial expressions have been suited. Ethical considerations and confidentiality. Here, the ethical implications of using facial recognition technology, particularly in sensitive contexts such as mental health, to ensure that the confidentiality and consent are prioritized in system development and operations. Here, the objectives are to develop a machine learning based facial expression recognition system that enhances the ability to recognize and classify the emotions in individuals with intellectual disabilities, to integrate advanced feature extraction technique to improve the accuracy and robustness of the facial emotion classification, to explore and implement machine learning models like SVM for real-time facial expression recognition, enabling better emotional interaction for individuals with intellectual disabilities. This is the how the flow of the model. Here, the input image is taken, and the pre-processing techniques here we can use. From after that, some of the feature extraction techniques that extract the features, and these give to the input to the SVM classifier, and then the SVM classifier track the face emotions and classify these emotions into these 7 categories like happy, sad, fear, disgust, surprise, anger, and neutral. Here, we have created our own data set, and for evaluation, a FitNet data set is used. All these 7 categories, I already told you that. In pre-processing, face detection is used for cropping and aligning the face in images. Noise removal techniques, cleaning the data for better feature extraction. The normalization is used for resizing to the fixed dimension for height and width, convert to grayscale, apply the histogram equalization, and the data augmentation for rotation scaling and horizontal flipping to enhance or to increase the dataset variability. Then the feature extraction techniques, the first one is the facial landmark detection. In the facial landmark detection, we can detect and to capture the key features like eyes, mouth, or jaw lines or eyebrows from the 54 or 68 point facial landmark detection. Then next one is the Gabber filter. In the Gabber filter is a convolution filter representing combination of Gaussian and sinusoidal form. The Gaussian theta component provides the weights, and the sine sigma components provide the directionality. Gabber can be used to generate the features that represent the texture and edges. Here, one filter is not enough, so we are using the set of features here. Then the next one is the histogram. HOG, histogram of oriented gradients. Here, the in the start, we can crop the image of a size that we have to fix that image to resize into 64 by 128 pixel size. Then that 64 by 128 pixel size or that patch is divided into the 8 by 16 grid. Every block of the grid is 8 by 8 pixels each. For every block, we calculate the feature vector of size 9 and then combine 4 such feature vector in adjacent block to create the concatenation feature vector of size 36, and this can be repeated for each row and for each column. So we have so we got 7 by 15 feature vector of size 36. So here the HOG feature length is 3780 approximately, and here we are using the SCVM classifier for small to medium data set, and decision function and classification outcome is used to classify in the 7 categories. These are my results. Here the happy, sad, surprise, anger, fear, disgust, and neutral. All these 7 categories are categorized by the SVM, and these are the results. Here, the accuracy is approximately about 92% of my research. So, at the last, the conclusion here, they presented a machine learning based facial expression recognition model for individuals with intellectual disabilities, leveraging to SVM as a classifier and utilizing facial landmark detection, Gabor filter, and HOG for visual extraction. The model achieves 92.5 accuracy while providing a fast and cost effective solution for individuals with intellectual disabilities. Here, the future research should focus on improving accuracy through advanced deep learning technique and data augmentation to enhance the real world applicability. So these are my references. Thank you.
Yeah. Hello.
Yeah, thank you so much, sir. Now it's time for the questions.
Dr. Amol, good work.
Thank you, sir.
Question is, you title says with disability intelligence, right?
Yes, sir.
So how can you, how did you cover it in your work? Intellectual disabilities.
Intellectual disabled, sir. I have created I have taken the pictures of these peoples. I am from Jalgaon, Maharashtra. In our city, there are near to my city, there are 2 to 3 schools are there for these peoples or these childrens. So I have taken the pictures or images from them.
So you mentioned about the 2 sources of data set. One is readily available, and other is you created.
Yes, sir. So the
What
affected
about the
data set.
existing data set?
Affected data set is for evaluation purpose. I am using there, but actually the whatever the actually, sir, the problem is that this type of data set is not readily available. These cognitive impaired persons, we have to take we have to create our own data set for these people.
Did you also observe the similar 8 classifications of the expression in the intellectually disabled people? Yes.
Actually, sir, not clearly as compared to the normal people, but somehow we can take the expressions, or we can withdraw the expression from their faces, or at least we can say that the a particular child is ready to take medicine, or this child is feeling happy, so he can able to take the medicine. Okay, or if he is in the acceptance mode, then the educator can educate that particular person. But if that person is in the angry mood, so at that time the educator or the caretaker can ignore that particular time, or they cannot offer the medicine in that particular time, actually.
So the last one, what is the limitation of your work?
Sir, actually, it in the limitation, it is very difficult to take their expression, or the delay response come from this type of people.
Is
Or
but the limitation in your work, I mean the future work, someone wants to extend
yes,
it.
yes, yes, sir. Actually, sir, actually here my mentor advised me to start from KNN and SVM. So in the future, I will use deep learning techniques, or I'm using the CNN or RNN or hybrid approach, and some future extraction technique to more precise, or to more accurate my study.
Okay, thank you.
Thank you, sir. Thanks a lot.
Thank you so much, Dr. Amol Chaudhary. Moving on to the next paper ID 125, NSAP, a neural network based stress analysis pipeline using EEG topographic images by Dr. Nandu J.
So am I audible?
Yes, sir, you are audible.
One second.
Dr. Amol, you can now stop sharing your screen.
Oh, I think I need to quit and reopen this room because there is some Can you see my screen?
Yes, sir, your screen is visible. Sir, please turn on your video as well.
Okay, one second, one second.
Yes, no problem.
You can see me, right? Hello?
Yes, your screen is visible. You can now start present.
Hello, you can hear me, right? Hello?
Yes, your video is clear.
Can you hear me?
Yes, now it's visible. Yes.
No, can you hear me? Yeah.
Yes, you are audible also.
No, can you hear me? Yeah, okay. So good afternoon. I'm going to present the paper titled NSAP, a neural network-based stress analysis pipeline using EEG topographic images. And my co-authors are Professor Jia Sinha from GSFC University and Professor Vinoy Venugopal from IIIT Bangalore. So these are the table of contents. Introduction. So why stress detection matters? So the stress is more than just feeling overwhelmed and can lead to serious health issues like anxiety, depression, high blood pressure, and heart disease. And if stress is detected early, interventions like relaxation techniques or meditation or professional support can help to prevent these long-term health problems. So the challenges with the existing stress assessments. So the most stress assessment depends on people filling out surveys or talking about their feelings. This can be unreliable because people may not recognize their stress level, so they may underreport their stress. So some accurate methods exist like cortisol test, but they are invalid and not practical for daily use. So we need an approach that is both accurate and comfortable for regular monitoring. So our approach uses EEG-based stress detection. So EEG measures the brain activity through sensors placed in the scalp, and the EEG provides both direct insights into the brain stress responses, allowing us to detect stress objectively. So our approach can even be applied in case where the individuals are unable to communicate, such as people in medical conditions like coma or those with limited responsiveness. So these are the overview of the project, and it is divided into multiple stages. And the first stage, we collect the data, and we will be converting these EEG signals into topographic images, and we will train a CNN model to differentiate or classify it into it is a binary classification to classify it into a meditation phase and a non-meditation phase. And next, we input a sequence of topographic images, and we will collect the prediction sequence from it, and its length is normalized. And next, these prediction sequence will be given to a CNN LSTM model. And based on the experience level and the state, that is, if a person is already experienced in meditation and or if a person is novice in meditation. So like that, we will convert it into 4 states. And it is a known fact that a person who is already experienced in meditation will be having a very low stress. So the brain activity or the focus level or the prediction sequence, which we get from the CNN model, will be showing a person who is having a low stress level. Next, for an explainability purpose of the model, so we create synthetic data, and it will be fed to the CNN and LSTM model, and we will see what parameters of the signals are contributing to each stress class. So these are the objectives of our project. First, we want to check whether a CNN model is able to distinguish between the topographic images of people who is meditating and non-meditating. Then we want to develop a non-invasive way. That is, we don't want to give an external stress while taking the data. So for this stress detection model, then we want to investigate the contribution of different EEG frequency bands for stress classification, and also to classify it into 4 stress levels. So materials and methods. So first, we collect the data while the people, the individuals are meditating, and while they are not meditating. So 20 minutes data will be EEG data will be collected from them while they are meditating and while they are on a resting phase. So we used an 8 electrode EEG device for this with a sampling rate of 500 Hertz. And the topographic image is generated using an MLD library. It is an open source library which is available in Python. And it will be then using a bandpass filtering, we will be converting it into different bands, frequency bands. And for each frequency band, we will be creating a topographic image. So we will take a 0.5 second segment from the EEG, from the 8 channels of the EEG, and then it will be converted into different bands. And for each band, the topographic image will be generated. And you can see the electrode placements in this calc. So if you want to see that the FP1 and FP2 are placed at the frontal cortex, and like that the O1 and O1 and O1 and O2 in the occipital area. So in the stage, the first stage, we use a binary classification. So we created 5 distinct CNN models named alpha, beta, gamma, delta, and theta CNN. So for distinguishing, for classifying these topographic images into meditating and non-meditating state. And in the second stage, we feed the sequence of topographic images to the CNN, and we will take the prediction sequence. So this each sequence encapsulates a dynamic transition of brain state over time. So even though it's a binary classification, and the value it will be giving will be from 0 to 1, and it will be showing a transmission from the state of the brain. So in the next stage, like I said earlier, we will be converting these into 4 classes. The prediction sequence from the 4 class of people, which is experienced who is meditating, to novice who is non-meditative. So the experienced meditating persons, the change of the focus level will be showing similar to somebody who is having less stress. That is the foundational idea of this project, and it will be fed to the CNN and LSTM. And and next we used a model explainability. So we used differential evolution. So it will generate a lot of synthetic data, and it will be fed into the network. And there are some 5 parameters we choose: baseline, fluctuation, trend, noise, and frequency. And we will know what parameters what values of these parameters contribute to the lower stress. And these are the results from the stage 1. So from this, we can understand that CNN model was able to distinguish between these a person who is meditating and who is not meditating. And the gamma CNN gave the highest performance. That means the gamma CNN band will be showing the most variability when it comes to a person who is meditating and not meditating. And the second most performing model was the beta CNN. So these are the results from the stage 3. So stage 3, we inputted the sequence of prediction values. From this, we can understand that the delta CNN was the lowest performing model, which aligned with the non-association of the delta CNN will be evident when that person is in deep sleep. So so that's why it is showing the lowest performance. And the gamma CNN showed the best performance among all the models. And the model explainability. So even though our data was limited, but we just tried to see this, but I'm not stressing on these results. But it showed that the trend is showing the most positive correlation between the stress class. So it is showing that when the stress class increase, the trend will increase, and the fluctuation is showing the weak correlation when it comes to the stress class. And these are the implications and conclusions. So even though our data was limited, but we were able to distinguish between a person who is meditating and non-meditating. And also we were able to classify it into different stress classes. So these we created this project as a model way so that we can change. For example, in the third stage, instead of a CNN LSTM model, maybe we can use a transformer model in the future. So it's extensible design. And the future direction will be collecting more data and exploring the connectivity metrics. That means the different parts of the brain will be having a phase between each other. So we need to explore that. And transfer learning, and also this also for real time. We need to adapt this for a real time stress monitoring. So these are the few references. Thank you. Hello.
Yes. Am I audible to you?
Yeah.
So, how did you generate the synthetic data?
So it's using a differential evolution. So it is there. We used a differential evolution from SciPy library. So
Which one? Which
we have
library?
these parameters or SciPy.
So, I mean, it's
Hello.
I mean, so you have how many records are there?
What records?
The
EEG
synthetic
device.
data. EEG.
Okay, so there are 200. So the differential, how differential evolution works is like we generate about 50. So we can give all these parameters. These are hyperparameters. So what we give us, we create 50 different these synthetic sequence at a time. So at first it will generate some random sequence and it will be fed to this this CNN LSTM model and check how accurate it is. Then it will change it.
See,
Change it and it will be.
Nanduji, my question: what is your data set size?
Okay, EEG data set you are asking?
Yes.
So we collected data set from 10 individuals. So from each person, we will be collecting while they are meditating 20 minutes, and while they are resting 20 minutes.
So how many records are there? For how many?
So it will be, yeah, for 10 people, 2 records will be there.
So 20.
Yeah.
And then you generated synthetically how many?
Synthetically, as I told you that synthetic sequence we use just for the explainability purpose. For training purpose, we didn't use it. So synthetic data.
Didn't you think it's a very small for training purpose?
Yeah, it's yeah, data set was a very was the limitation for this project actually.
So then, okay. Okay, so that's it from mine. Thank you.
Okay.
So I have one question. You collect your own data set, right?
Yeah.
So when you collect your own data set, were there any ethical consideration? Ethical consideration you consider ethical side?
So actually, we will be asking their permission at first. And also, the data is not open source, but the topographic images are open source. But we are not giving out this data actually. Yeah.
Okay, okay.
Hello.
So, any other questions? If not, then thank you, Mr. Nandu. Then moving on to the next paper ID 135. Data visualization and analysis on groundwater of Samuda, Chhattisgarh by Ms. Shruti Karmakar.
Hello.
Yes.
Is my screen visible?
Yes, ma'am, your screen is visible.
Okay.
And please turn on your video as well.
Sorry for that because there is some technical glitch with my laptop, so I can't open my webcam here.
No issue, you can share without your video, it's fine.
Okay, thank you so much.
Yes.
Okay. Good afternoon, everyone. I'm going to present my paper on the topic data visualization and analysis on groundwater of Samudha, Chhattisgarh. So now, groundwater is a vital source of drinking water for millions of people, and especially in the rural areas. So, through increase in industrialization, agriculture activities, and urban expansion, there have been a lot of contamination and in the quality and the safety of the water. So, this study focus on the quality of groundwater of Samodha district in the Chhattisgarh, and by analyzing water samples from 45 different sites of that district. So we have used advanced data visualization technique, and through this we aim to assess the water quality, identifying the possible sources of contamination, and provide actionable insight for local authorities and residents. So by evaluating key parameters such as the water quality index, nitrate, fluoride, and pH level, our study aims to enhance the awareness and contribute to better water resource management in that region. So the objective of our study is to assess the groundwater quality. So for that, we have analyzed water samples from 45 sites from the Samodha district from Chhattisgarh. We have identified the contamination sources. That is, we have determined the presence of pollutants like nitrates, fluoride, and pH imbalances in the water. To utilize data visualization, we have used the Power BI to interpret complex water quality data and provide actionable insight for that we can offer recommendation for improving water safety and resource management. So our study area is the Samodha Nala watershed that's situated in the Durg district of Chhattisgarh state. The watershed is 117.45 kilometers square in area. It consists of one of the major industrial areas in Chhattisgarh, that is Bhilai Steel Plant, Associated Cement Companies Limited, ACC Mines, agriculture areas. And the area is located between the latitude and longitude of 810 degrees to 810 degrees 24 minutes in the survey of India. The region is warm semi-arid, has a warm semi-arid climate with annual rainfall of 130 millimeter, and the southwest monsoon is the major source of rainfall in this area, and the area surface temperature varies from 100 degrees centigrade to 400 degrees centigrade with more than 55-degree humidity. So this map shows the actual location of the Samudra district. So this one is the map of India, and the yellow region is the Chhattisgarh region, and in the second one, in this Chhattisgarh region, the red mark is the Samodha district, which has been uh, depicted in this. So this is a thematic map. The first figure shows the water level of the Samodha district. The red region mark where the region we have the more water level, and the green are those which have very less water level. And the second one is the ground potential zone of the Samodha region. So our data set is contains the groundwater samples that was gathered and collected from the 45 location in Samodha district of Chhattisgarh. And this data set was collected, and each sample was tested for key water quality parameters that include water quality index, that too overall assessment of water suitability for drinking, pH level that measures of acidity or alkalinity in water, nitrate concentration, that is the high levels of this may indicate the contamination from agriculture, runoff or sewage, and fluoride levels, that is to ensure that is essential for dental health, but harmful in excess. So we have used a data visualization tool. For that, we have used Power BI that was used to create interactive dashboard for better understanding of spatial and temporal water quality variation. We have created graphs and heat maps to highlight the areas with high contamination level. The findings were compared against national and international drinking water quality standards, and based on the result, recommendations were provided for water treatment and resource management strategies. So the tools that we have used is the Power BI for visualization. So it's providing a very interactive dashboard for visualizing the data. So the features of Power BI is that it provides seamless connectivity to various data sources like Excel, SQL, Azure, Salesforce, Web APIs, and also to the unstructured data. It provide data transformation and modeling by Power Query Editor for cleaning, transforming, filtering, grouping, merging data, and enables creating relationship between the data set. It provides interactive visualization, that is customization visual like charts, graphs, maps, tables with drill down and filtering option that supports interactive dashboard. So this figure shows the interactive dashboard using the Power BI. So there are visualization tools in Power BI like bar chart, pie chart. We can plot scatter, plot, histogram, line chart. These are the various options that are available in the Power BI. And also we can have the data analysis and AI insights. That is, we can integrate AI features like machine learning, NLP, and forecasting and report and dashboard sharing. The report that have been generated and the dashboards can be shared using the Power BI service and from mobile applications also. Real-time data and alerts. This tool also supports real-time data streaming and updates with alerts for data threshold and changes. We can also integrate with the Microsoft ecosystem. That is, it provides seamless integration with the Excel, Microsoft Excel, Teams, SharePoint, Azure, and flexibility with non-Microsoft applications. So this is very useful tools for an office or corporate organization. So water quality index. So this is a table shows the water quality categorization that according to the Canadian Council of Minister of the Environment Water Quality Index. So these are the WQI value, and if the value ranges between 95 to 100, then the water is excellent for drinking, and if it the minimum is if it lies between 0 to 44, then the water is very poor. So in between, the water can be termed as good, fair, and poor. So now this is the first bar chart that been generated using the Power BI that shows the location which have the water that could pose a health risk based on the water quality index. So the x-axis shows the sample number. So as we said 43 sampling points, and this is the average QI. So the average WQI values for different sample numbers were visualized to identify trend across the region. So which region have the good water quality index and which have the lesser water quality index. As shown in this figure, certain areas exhibit significantly lower WQI values, that is, have the very poor water quality. So we have also done the sustainability or unsustainability test by using this pie chart that visualize the portion of water samples suitable for human consumption. So this was done to prevent the races. That is, we can have access to clean water, so we can reduce the waterborne diseases like cholera and typhoid, and a reduction in toxic exposure, that is safe water prevents harmful chemicals like lead, mercury, and arsenic. To improve hygienic, that is clean water promotes better hygiene practices and reduce infection. Improved growth in children, that is safe water aids in better nutrition absorption and healthier development. So this pie chart shows that the 66.67% of the water in that district is suitable for consumption, and 33% is not suitable for consumption. So this plot shows the nitrate and fluoride trends in the water samples. So the effect of nitrate in the water basically originate from the agricultural runoff, sewage, and industrial waste. So as this district is surrounded by the various industries like BSP and the cement industries and have the agricultural land, so it have some high level of nitrite, and if the water had the high level of nitrite, so it can cause blue baby syndromes in the children's, cancers, thyroid issue, and the safe limit for nitrite is 10 mg per liter. Fluoride is a natural occurring or added for dental health, but high level can cause dental fluorosis, skeletal fluorosis, and potential neurological effect. So for this, the safe limit is 1.5 mg per liter. So we have also done the pH analysis using the scatter plot. So the purpose of this to show the water, if the water samples are within the neutral pH range. So if the pH is less than 6.5, so water seems to be acidic, and it's greater than 8.5, water seems to be alkaline, and the optimal range is 6.5 to 8.5. So here the pH range is the water is mainly the alkaline water. It shows it's the pH range between 7 to 8. Sorry, it's lies in the optimal range. We have also plotted the key influences of water quality. That is, the purpose was this to discover what are the factors that influence whether the water is classified as excellent, good, or poor. So we want to classify the water in terms of this. That is, the water is excellent or good or poor in the quality. So for this, we've included certain chemical parameters like calcium, chlorine, fluoride, nitrate, and pH. So this is the plot for this. Uh, so this shows the water is good for drinking. So now the finding of the study is that the study provide a comprehensive analysis of
Ma'am,
groundwater quality. Yes.
ma'am, your time is up, so if you could wrap up quickly.
Yeah, I'm just wrapping up. Quality in Samodha, Chhattisgarh, that revealing that both safe and contaminated region. So the first is that water quality index analysis. 60% of the samples indicated water suitable for the drinking, and 25% shows that shows moderate contamination that require minor treatment, and 50% show poor quality that making them unsuitable for direct consumption. And for pH level variation, the pH ranges between 6.5 to 8.2, indicating slight variation in acidity and alkalinity. So 5% of the samples were found to be slightly acidic, while 10% exceeds 8, making them mildly alkaline. So for fluoride levels, we found that 12% of the samples had fluoride concentration exceeding 1.5 mg per liter, posing a potential health risk for long-term consumption. So, and certain regions exhibit elevated fluoride levels, require intervention to prevent skeletal and dental fluorosis. For special contamination trends, we found that the northern and the western region of Samodha had relatively better groundwater quality, whereas the southern and the central area showed higher contamination, particularly in nitrate and fluoride levels. So what were the implication is that implication of this finding is done for the public health. That is, we can provide the safe water, or safe drinking water to the people.
Ma'am,
Yes.
ma'am, we are
Yeah.
running a little late on time, so let's continue with the questions now.
Okay.
Yeah, hello.
Yes, sir.
Good work. You did analysis of groundwater. The only question is regarding the WQI. That is, you mentioned about the Canadian standards. Do we have our own standard in India?
So that we are using this standard only, so I don't know much about that.
Okay. So exactly what is, I mean, in the water quality, what we looked into it, into the water, how we can say the excellent, good, and all this.
So for that, we have used this key parameters like the presence of calcium, chlorine, fluoride, nitrate in the water level. So based on this, we found
Okay,
that we have a
the
yes, sir.
WQI up to which range is drinkable?
Sir, the best is we have shown here that 95 to 100, but with I think 65 to 79 is fair for drinking, but needs some treatment, minor treatment before drinking. But from 80 to 100 is good for drinking.
Okay. Okay, so that's it. Thank you.
Thank you so
Sir,
much,
I'm
sir.
a co-author for this, Dr. Mridu, and she is my scholar. And you asked the question that for the Indian standards.
Yes,
Sir,
yes.
actually, these things are based on this, the which type of water we are treating. So here, the thing is that we are treating the groundwater. So the standards are different. If we are treating the surface water, then the water quality parameters and these things are different. So this will be depending upon the region to region also, and we are fixing that the weight values to the particular ions.
Okay, thank you.
Yeah, thank you so much.
Thank you so much, ma'am.
Thank you.
So, little
Thank you.
announcement. We are running little late on time right now. So, the time for the presentation will be 8 minutes, and the time for the question answers will be given 2 minutes, and only one question from the session chair will be accepted. So, let's move on with the next paper number 144 towards enhanced wall stop spotting in historical Devanagari documents using deep CNN architecture by Dr. Surendra Ramteke.
Hello.
Yes, sir.
It is audible, madam. I have shared my screen. Check it.
Yes, yes, it is visible and you are audible.
Okay. Thank you. Thank you. Just a minute, madam. Just a minute, madam. Just a minute. I'm going to share my screen. Is it visible, madam?
Yes, your screen is visible and please turn on your video as well. You can start with the presentation. The timer is going on.
Yes, yes, madam. Yes, I will finish. Good afternoon. Myself Surendra Ramteke, and going to present my paper on a title. I think it is toward the enhanced word spotting in historical Devanagari document using a
Sir,
deep
please
CNN
do the
architecture.
full screen.
Yeah. Now it is okay?
Yes, it's fine.
Fine, thank you. So good afternoon, respected Sinha sir, honorable session chair, faculty coordinator, and researchers. My paper title is Toward Enhanced Word Spotting in Historical Devanagari Document Using a Deep CNN Architecture. The flow of presentation is introduction. What is Devanagari script? The motivation for the research, literature survey, problem statement, objectives of the research, deep CNN model, result and discussion, conclusion, and references. So basically, the India is multilingual country and it is a rich heritage of the ancient document. Basically, the historical document is here I'm going to use for the word spotting. Basically, the lot more important information the religious information, the philosophical, mathematical, and medical knowledge, it is there in this particular document. And preserving this historical document remaining the challenge due to their higher fragility and the ages. Many government institutions and the private institutions are actively working on digitization this document for the cultural storage and the future generation. So many Indian manuscripts are now digitally accessible and it is available for the global search. But searching with the image based document, it is challenging. So here, one of the research efforts we are going to take to find out the word spotting uh, in the historical documents, and it's avoid the full OCR based text conversion. So basically, what is Devanagari script? It is one of the most widely used script. It is used in the India, particularly used for writing the language like Hindi, Marathi, Sanskrit, and the Konkani. So in my focus of work, it is on the Maharashtra, and in the Maharashtra, it is the state of the India. The Devanagari script plays a vital role in the documentation and preserving this historical culture. Basically, when you are going to focus on the features of this Devanagari script, the important parameters here, that is the consonants, vowels, and the modifiers. Again, the modifiers, it is of the two types: upper modifier, lower modifier, and the Shirorekha. Ligatures and the directions. These are the features that is there. So basically, the motivation to do this research is that word spotting is the challenge due to the variation in the writing style among the different authors. Even though we are going to write the same particular task, so we not write the same thing repeatedly. Okay, so it is a writing style, changing writing style is there. Then ancient document, suppose I am going to focus here, it having these two slants, broken words, letters, and non-text elements like a symbol. So historical documents suffer from the degradation issues such as missing data, the quality is poor, aging effect, and also more time the noise it is eliminated during the document scanning. So here this is the focused area, that is the historical and cultural preservation, information retrievals, and the document understanding and the document analysis. And from that we are also focused on the education tools. So this is the literature survey. Gone through the various the research paper. It is available on this particular different various languages. Okay, I'm not going to details into this. Only the parameter that I have considered here, the basically the which techniques they have used, the merits, demerits, and the types of the data set, and the performance matrix, which include the accuracy, precision, recall, and the measure. So basically, what the problem statements have framed here, the retrieving the information from the handwriting historical document is challenging because of the its complex layout, writing styles, and the document degradation. And here, while digitizing the preserve these records, it is insufficient for the researchers who can need and assess and the index content. So field transcription, it is not practical due to the poor preservation, script variations, and the obsolete language. So this research is aimed to develop the advanced method for the automatic extraction and the retrieval of the information from the ancient documents, addressing the challenges to enhance the accessibility and usability of the document. So the objectives of the research is that we are going to study and analysis of the existing methodology. It is applied for the printed, handwritten, and historical document for the various scripts such as English, Arabic, and the Devanagari. Prepare our own data set for the ancient handwritten Devanagari document. Design and implementing of the proposed solution for the word spotting, and comparing the results with the existing system. So here, the deep learning convolution neural network basically we have used here in this this particular research work. So it consists, you know very well that this consisting of the various layers. That is input layer, it is used for the pre-processing the word images, the size normalization of all the input images with the fixed dimensions, then convert these images into the RGB2, the grayscale images, then feature extraction. So here, the different convolution layers, we are going to use the first few layers, detects the low level features of the images like the edge, corners, and the texture. As the depth increases, the network learns the mid-level features like the character shape. Then we are going to find out the curve, and then final convolution layer capture the global word structure and the pattern. So then obviously along with that, for the dimensionality reduction, max fully reduces the size of the feature map while preventing the essential information, and also this dimensional reductions helps for the CNN becomes the translation variance, means there is a shift in the handwriting, and it does not affect the recognition. And finally, the full connected layer pattern feature map are passed to the fully connected layers. This layer convert the extracted feature into the vector representation, and this vector represents the word in the high dimensional space, while similarity words are close together, and compare the query words with the stored data set, and we are going to find out this particular word it is a match or not. So for this experimentation, we are going to find out the accuracy, precision, recall, and the F measure. The experimenter is done on the own data set. Basically, we have prepared our own data set of the around 1,000 documents that it is collected from the Rajwadi Mandal library of the ancient documents. It is available in the Dhule district of the Maharashtra, and we are compare the results with the existing system along with the HMM model and the SVM model, and which indicate that the CNN performs well on these tailor-made data set. So these are the results. So we are going to test the results with the batch size of the keywords, that is 200 to 1000. And here the accuracy of the CNN, it varies from 96.0% to 95% for the CNN model, and it is a somewhat promising one as compared with the HMF and the SVM model. And this graph shows the comparison results. And again, we are finding out the precision for the same batch size for the 200 to 1000, and recall also, and the F measure also. Okay, so the conclusion, the deep CNN model outperforms over the HMM and the SVM to handle the degraded handwritten Devanagari script with the higher accuracy, precision. So the ability to process the structured data set makes it ideal for the text analysis in the noisy environment. Basically, whatever the data set that we have collected, so it is from the 15th centuries, and all this data set are very noisy ones. The feature focus of our research will be extended on the other script basically, and the time sensitive tasks, and also the main approach is that we are going to use the hybrid deep learning model along with the optimization techniques and the advanced preprocessing techniques, so which will improve the accuracy again, and the potential applications which include the document digitization and multi-level data processing. So these are the references that we have used for our research, and thank you.
Yeah, hello. Thank you.
Yes. Yes,
One
sir.
question only. Like you applied deep learning, so have you seen the work, or have you tried converting image into text and then applying machine learning, deep learning?
Sir, it is possible here, but actually whatever the data set we have collected is in the image form, so it is not possible to convert it to the text. So we have used directly. We are converting that images. We are applying that images directly, and
Okay,
find out the. We are going to find out the work there. Actually, we are already implemented the SVM and the HMM model. So in that case, we have to do the processing, that is the segmentation. The crucial part is the segmentation, sir.
Okay,
So
understood.
we are propose the methodology, that is we are going to find out the height of the lines, actually the words, and based on that check it whether there is a modifier there, or upper modifiers or the lower modifiers. This is the issue, and the segmentation of these documents, it is a crucial task, sir.
Yes, yes. Okay, fine. Thank you.
Thank you.
Thank you so much, sir. Now moving on to the last paper ID 76,
madam.
optimizing real-time facial recognition through image brightening and feature enhancement techniques by Mr. Rahul Thambi.
Hello. Yeah, am I audible?
Yes, sir, you are audible, and one request that if you could present it briefly as we are running out
Yeah,
of time.
sure, sure.
Thank you
Only
so
one
much, sir.
request, since I'm working right, I'm in office right now. I'll be sharing the screen via my phone. That's all right, right? Is that fine?
Yes, sir, it's fine.
Yeah. Let me know if you can see my screen.
Yes,
Yeah,
sir,
is it
the
visible?
screen is,
It's
yes, it
yeah,
is visible.
yeah. Can I start?
Yes, you may.
Okay, so hey guys, I'm Rahul Thambi. I'm from NMIMS Mukesh Patel. I'm in my final year right now. So basically, my research paper is on optimizing the real-time face recognition through image brightening. So basically, we had created for the final year project, we had created smart glasses called as Arise, which we got inspired by Edith glasses from the movies. So basically, this particular research paper focuses on one of the features which I had in my capstone in my final year project. So yeah, I'll just start off. So as just for the brief introduction, since we all know that face recognition is widely used in a lot of key areas in our day-to-day life, be it authentication, surveillance, or security. So the main highlighting point of our research is that rather than using just a stock data set, let's say YOLO V5 or some other model, we have curated a custom model for our smart glasses. So that's where we have used the Clahe and the gamma correction enhancement techniques of the real-time recognition. So the problem with our what the problem we were facing is that we were using an Arduino-based camera for our smart glasses. But the thing is, the normal cameras which we use in our day-to-day life, that is the phone camera or a webcam, it shoots in 30 or 60 frames per second. But a Arduino Nano, the camera used in that, it shoots at around 5 FPS. The problem which we were facing is that since due to lack of frames per second, we weren't getting a good quality image. And if even if the light is not in an optimal condition, be it even a bit darker than usual conditions, the camera just completely shuts down. Like the image which we get from the camera was not usable. So that's where we used Clahe and gamma correction, wherein Clahe was mainly used for detailing purpose and gamma correction basically brightened up the images so that it was usable for further uses. Wherein particularly in our project, we were using face recognition for Alzheimer's patients, wherein let's say you encounter a person for the very first time, or you're encountering a person for, let's say, a family member. So for Alzheimer's patient, be it if it's their initial stages of Alzheimer's, or even if it's their final stages, you can't really suppress that. Suppress the Alzheimer's, right? So, in order to help them recognize the loved ones, we established a face recognition wherein the person who comes in front of them, the glasses automatically detects the person, and then their name, their address, the contacts, the relation to you, all of them was narrated. So that's where we use Google text to speech as well. So yeah, basically for our objective in our project was to recognize people as well as to save new people. For example, rather than noting down the contacts of a new person in my phone manually, I can just ask the glasses to let's say a new person comes in, I can just ask, okay, save this person on my contact list, and the contact was saved as well as the face corresponding to that particular contact was saved in the gallery. Yeah, as for the materials and methods, the hardware was a normal webcam used in Arduino Nano, and as for the software used OpenCV DLP face recognition, Python SX3 for text-to-speech recognition, and the techniques which we prominently used for Clahe and gamma correction. And the the data set which we used was around, so the custom images which we used were around 86. Apart from that, all the other images, it was trained using a pre-trained model, so which we took from GitHub. Yeah. And then as for the results, right? So we wanted to focus our goal particularly on not that well-lit conditions, right? So in well-lit conditions, it was performing very well. It was 95%. And in challenging conditions, due to our Clahe and gamma correction improvement, it was 87%. Before it was around 75% without those improvements. Then, yeah, as for further results, let's say earlier, Clahe and gamma correction, the time it took to recognize a new face familiar was around zero point 0.5 seconds. For example, if a new person was coming in front of the camera, it took around 2 seconds to save the image of the person. Yeah. So to conclude, we were able to complete this project around in 2 months, and then we further expanded our horizon to not just focus on Alzheimer's patient, but we also use the same technology for other projects, wherein it included security and surveillance, a personalized system for smart assistants for recognized users, as well as for accessibility in day-to-day lives. As for the references, there were as for yeah. So the thing is, for Clahe and gamma correction, there were different papers wherein they both focused on Clahe and gamma correction solely, but none of them combined both of those techniques together. So all the papers which we referred were from 2023, 2024, or some older ones which wherein Clahe was just introduced. So we combined both of those techniques to come up with a model which was much better performing than the ones which was already used. Yeah, that's it.
Yeah, hello.
Yeah,
Thank you.
yeah.
One question is regarding, is it the facial recognition binary classification or multi-classic?
It was multi-classification.
So what are the categories could you, I mean, you could identify
Uh,
different
as
classic?
All right. So since we were using a pre-trained model for the initial classification, which was face recognition, the library, it worked on various parameters such as the distance between the nose and the eyes. And then so the four key parameters were the distance between the eyes, nose, mouth, and the ears. So yeah,
Yeah, these are features is fine, but the classes, which classes?
classes as per, can you give me an example of what you're expecting?
The number of classes you could classify
All
the.
right. Okay. Yeah. Yeah. So there was no fixed classification because it's based on the computing power, right? So it doesn't matter. It's not fixed for like let's say 5 or 10 classes. It was as and when new faces came into picture, the classes horizon extended so as far as possible.
Okay, okay,
Yeah.
thank you.
Yeah. Yep. I'm so sorry, guys. I couldn't able to start my camera due to confidentiality in the office.
No, it's fine. Thank you so much.
Thank you so much.
So there was a issue with the paper number 120 of Dr. Cheche Kher. So are you able to present now?
Yes, I am ready.
So if you could like quickly, briefly present it.
Okay. Okay. Let me share my presentation. Hello.
Yes, you are audible.
Hello.
Yes, your screen is visible.
Okay. Can you hear? Can you hear my voice?
Yes, your voice is audible, but I can't see your video.
Okay. Can I start my presentation?
Yes, you can start it.
Okay. Good afternoon. My name is Jyoti. I am presenting from IITB, Bangalore. My paper title is an innovative robot piano for piano performance using Lego Milestone EV3. The next slide. This is our member. I would like to give special thanks to Professor Sinha by Challenger, GSFC University, other faculty member, Dr. Miu Miu Ang, Dr. Phu Miu Tue from Myanmar Institute of Information Technology, MIT. Yes. Let me introduce. Robot piano is a robotic hand that mimics human hand movement for piano playing. Based using Lego Milestone EV3 component, Wabi interface allows user to select sound and view lyrics, build robotic engineering and artistic expression in music. This is our objective to develop a robotic hand to integrate Lego Milestone EV3 component for automation, to design a web-based interface for sound, slashing, and lyrics display. To enhance educational engagement in robotics and music. This is a material you. We use Lego Milestone EV3 core set, 6 bar and 8 pension set, 2 bar. 12 large motor and 3 EV3 brake. There are many pieces in the Lego Milestone EV3 bar. We use the pieces to build robot piano, robot hand. This is the brain of our robot piano, robot hand. We use 3 EV3 brake, 2 brake for melody note, and 1 brake for chord note. So we namely have the two the two memory brick and one corporate. We can connect up to 4 motor and 4 sensor to a single EP3 brick by using EP3 DEP open source operating system. It allows user to program various programming languages such as Python, C, C++. You can develop a band project with the EP3 DEP operating system. This is the last motor, powerful smart motor. It has a built-in rotation sensor with 1 degree resolution for precise control, run at 160 to 170 RPM. This is the method. This is then consists of 3 main parts. Robot hand. We build robot hand using Lego milestone EP3, 12 motor and 3 EP3 blade. We build WebP interface by using JavaScript for front end and Python for backend. For software communication, use USB module to send command to EP3 blade. This slide shows connection between motor and piano node. 3 EP3 blade control melody and chord node. In motor, press 2 piano key by rotating 35 degree clockwise and anti-clockwise direction. In the version 1.0, we can play only 8 notes. In the version 2.0, we can play 24 notes by synchronizing motor movement. This slide shows for melody bridge connection between motor and piano note. For a single bridge, we can connect 4 motor and 4 sensor. For motor A, connect with note piano note C and D. Motor B connect with piano note E and F. Motor C connect with piano note G and A. Motor D connect with also B and C. The next slide for second melody bridge connection on motor and piano note. This slide also for corporate connection between motor and piano note. In the version 1.0, use a color sensor and color cut phase issue with inconsistent playback and limited sound rate. Version 1.0 can play the sound Ministry of Science and Technology theme song, Alakabami Beautiful War song, Myanmar Tinjan Festival song. Let me show with this demo. Version 1.0 play Myanmar Tinjan Festival song. This slide, key improvement in the version 2.0. replace color sensor with a web-based interface to eliminate lighting issue. Add more EV3 play and motor, increases the number of playback key from 8 to 12 now, improve accuracy and reliability of sound playback, enhance user interaction by allowing sound selection and library display through the web platform. This is our web-based design, and this is home page. We navigate play note, sound, gallery, and about us session. Let me show with this demo. This is the results of version 2.0. The sound is Ministry of Science and Technology. This sound, let me show. Okay. This is the version 1.0 version 2.0. Regarding sound playback method, version 1.0 use color sensor and color gap. Version 2.0 use web-based interface. Challenges in the version 1.0 inconsistent playback due to lighting condition. In the version 2.0, resolve color sensor issue with web control. Number of EV3 break. Version 1.0 use 1, version 2.0 use 3. 2 for melody and 1 for chord notes. Number of motor use 4 large motor and 12 large motor in version 2.0. Playback piano key 8 version 1.0 8 key. Version 2.0 can play 24 key. In the sound limit sound rate, version 1.0 can play only 8 key, so sound rate is limited. In the version 2.0, playback piano key is 24, so expanded sound selection sound rate. Accuracy and reliability lower due to sensor limitation, higher version 2.0 higher with direct web-based control. Implication, technological impact.
Excuse me.
So
So your time is up. So if you could start with the question answer.
Okay.
Yeah, you have really done a good work. The hardware implementation is really difficult.
Thank you, sir.
Yeah, I mean, the only question is like, which, I mean, the microcontroller or what did you use in that?
Use ready-made EV3 braid.
Okay.
This is the brain or sorry. This is the
okay, understood. So what is the cost? That the cost you mentioned 1,38,000 Indian rupees.
In Myanmar, MMK about 33, around 33 just. About rupee is.
Okay. Okay, good. Thank you.
Dr. Chacha The.
Mingla Vasya.
Kaun hai?
Thank you so much for your support. This is my first experience for online presentation.
Good. Hope. Nekaun in Bangalore?
I am fine.
Okay. Good luck. Thank you for presenting.
Thank you, Professor.
Thank you so much, ma'am. Now coming an end to the event, I request Dr. G.R. Sinha to present Dr. Gohil with memento as a token of appreciation for his valuable contribution to this session.
Thank you so much. Let me start my sharing.